So in this video, we're going to talk about what is an antiderivative, how do you find them, what are the different rules for them, and that kind of stuff. So first, what is an antiderivative? So to answer that, let's go back to what is a derivative? So a derivative, so the derivative of f of x was where we applied all of our different rules. So we had the power rule, we had the sum rule, the product rule, all of those different ones. So for example, we would say that the derivative of x squared is 2x. An antiderivative is where we start over here and our answer is what was in the derivative function. So we say that the antiderivative of 2x with respect to x is equal to x squared. So now we're going backwards. I'm giving you the derivative, you're giving me the original function. As far as notation goes, typically for antiderivatives, we let them be capital letters, so f of x, and f of x, lowercase, is going to be your function. So let's talk about powers and exponentials. So first, let's look at a power. So let's look at the antiderivative of x cubed. So I want to know what's a function where if I take its derivative, I get x cubed. Well, the power should definitely be 4. But if I just look at x to the fourth, the derivative is 4x cubed, and that's not what I want. I want just x cubed. So I need to put a 1/4 here. So the derivative of 1/4 x to the fourth is x cubed, so that is an antiderivative. That's not the only one though. I could have 1/4 x to the fourth plus 2. If you take the antiderivative of that, you're still going to get x cubed. I really could have added any constant. Because of that, we say the antiderivative is 1/4 x to the fourth plus some constant c. So in general, this is our first rule here. So the power rule for antiderivatives. If you're looking for the antiderivative of x to a power, and this could be any power, fractions, negatives, positives, any power except for -1, you add 1 to that power and then divide by that new power, just like we did in this example. We added 1 to 3 and got 4 and then divided by our new power. So for example, what is the antiderivative of x to the 7th? So I would add 1 to my exponent and get 8, and then divide by my new exponent, but let's not forget that plus c on the end. There's always going to be a plus c. Now we also have exponentials. So what's the antiderivative of e to the x? Well, one function, again, this is, give me a function whose derivative is e to the x. Definitely just e to the x. But I could add any constant I want. So here's another rule. The antiderivative of e to the x with respect to x is e to the x plus c. Just like all the rules we have with differentiation, we also have all those rules for integration. So integration is where you're finding the antiderivative. If you remember, with derivatives, we would say that the derivative of a sum is the sum of the derivatives. Same thing applies here. So if I have two functions that are being added or subtracted, and I want to find the antiderivative, we'll just do each one separately. So I could just take the antiderivative of each one separately and then add or subtract them together. So let's look at x to the fourth minus e to the x. So I'm going to do each one of these separately. Let's start with x to the fourth. So I'm going to add 1 to my exponent and get 5. Divide by my new exponent, so I get 1/5 x to the fifth. And then I'm just going to subtract the antiderivative of e to the x, which is e to the x, and let's not forget our plus c. So that's the sum and difference rule. We also have the constant multiple. So the constant multiple rule is if you have a constant times a function. If you remember with derivatives, you just kind of brought the constant along. So I'm going to do the same thing here. Just keep that constant and then take the antiderivative. So for example, let's do 2x to the fifth. So the 2 gets drug along. So 2 times the antiderivative of x to the fifth. So the antiderivative of x to the fifth, I would add 1 to my exponent and get 6. But then don't forget, divide by that new exponent, and this is all multiplication. We also have a plus c out here. 2 times 1/6 is 1/3, so 1/3 x to the 6 plus c. We'll do one more here. How about 4e to the x? So this is a constant out front, so I'll have the constant 4 times the antiderivative of e to the x. The antiderivative of e to the x, just e to the x, and again, let's not forget our plus c. All right, now let's look at our trig functions. So I'm going to kind of recall here all the different derivatives that we know of trig functions. So I know the derivative of sine, so the derivative of sine is cosine. I know the derivative of cosine is negative sine. I know that the derivative of tangent is secant squared. We know that the derivative of secant is secant x tangent x. We know that the derivative of cosecant is negative cosecant cotangent. And I know that the derivative of cotangent is negative cosecant squared. So based on each one of these, we can have a new rule for integration. So my first one is the antiderivative of cosine. So now we're saying, what function gave me a derivative of cosine? So that's just sine x, and don't forget our plus c. Next, what's the antiderivative of sine? So what function gives me the derivative of sine? Well, it's got to be negative cosine. Don't forget our plus c. The antiderivative of secant squared, so give me the function where its derivative is secant squared. So that would be tangent x. And then you can keep going through here. So the antiderivative of secant x tangent x is secant. Continuing over here, negative cosecant x cotangent would be cosecant. And then lastly, the derivative of cosecant squared, because I have that negative to play around with, would be negative cotangent. So those are your trig functions. Probably these first 3 are going to by far be the most important, so you want to pay attention to those. But those are your trig functions. It's just a real quick example here. Let's look at the antiderivative of 8 cosine x. So the 8 is just going to stay. What's the antiderivative of cosine? That's just positive sine, not the derivative, the antiderivative. So 8 sine x plus c. And then lastly, we're going to talk about natural log and standard exponentials. So for natural log, I know that the derivative of natural log is 1 over x. What that means for me in terms of antiderivatives is that the antiderivative of 1 over x is natural log. So there's another rule. So for example, what's the antiderivative of 8 over x? So the 8, just a constant, that's going to stay. And then the antiderivative of 1 over x is natural log. And then lastly, our standard exponentials. So let me remind you of this. The derivative of b to the x. was natural log of b to the x. So in antiderivatives, so there's another rule, the antiderivative of b to the x is kind of like the derivative, only now we're dividing by the natural log of b. Let's not forget our plus c's on either one of these. So for example, what's the antiderivative of 2 to the x? Well, the derivative of 2 to the x is natural log of 2 to the x. But the antiderivative, we're dividing, not multiplying. And one more of these. How about the antiderivative of 10 to the x? So if we were doing the derivative, we'd be multiplying by natural log of 10, but we're not, we're doing the antiderivative. So I get 10 natural log of 10 plus c.